So in this session, we'll start with the next topic, which is GUI. So before we dive into the GUI topics, let's make sure we have a solid foundation before we start. So there are basic you will need no matter which widget you're working on. First is swing basics. So swing in Java is Java's built-in library for building graphical user interface, which is all the buttons, text fields, tables, sliders. We'll use which will come from Swing. So one important thing to know is that Swing is lightweight. It handles drawing and event processing inside Java rather than depending on operating system. The golden rule is everything in Swing runs on a special thread called the event dispatch thread, EDT. This thread is responsible for updating the screen and handling user actions like button clicks. If you block the EDT with heavy work, let's say a big file read or a slow calculation, the whole UI will freeze. So keep heavy lifting off the EDT. You can use tools like Swing Worker if you need background task, but for now just remember, don't do big jobs on the main event thread. Next we have is window anatomy. At the very top, we always start with a JFrame. Think of the frame as the window itself. So it has the little bar, the title bar, close button, and resize edges. So inside that frame, we usually place JPanel. A panel is just a container that holds components like JButtons for buttons, JLabel for text, JTextField for input boxes. Here's how you can picture it. Frame is the house, panel is the room, and the components are the furniture you put in the room. So to arrange the furniture, Swing uses layout managers. These are the rules about how components get positioned and size. There are several types. We have flow layout, border layout, grid bag layout, which is more flexible. We'll explore those as we build more complex forms. Now let's talk a little bit about MVC mindset. MVC stands for Model View Controller. So this is a design pattern that keeps your code clean. The model is your data. Think of as the information your app is working with. For example, a list of students or their grades. We have view. View is what the user sees. Buttons, labels, tables, so on. We have controller. Controller is what reacts to user actions like clicking a button or entering text. So the important part is try not to cramp all your program logic into a buttons click listener. Instead, keep the listener short. It should just call another method in your program that does the work. That way your UI code and your business logic stays separate and your program is easier to test and maintain. Like for example, imagine we have a button labeled add student. The button itself is a part of the view. So the action listener attached to the button is the controller. When the button is clicked, it just calls add student, and inside the add student you update your model, maybe a list of students objects. This separation is small, but it could be powerful. So Swing runs on the EDT, event dispatch thread. So don't freeze it with heavy work. And windows are built with JFrame, and panels hold the components. Layout managers decide how everything fits together. Keep the MVC mindset. Data is the data in the model, UI elements in the view, event logic in the controller. So don't let your listeners do all the heavy lifting. So with these basics in place, you'll be ready to tackle any GUI component you add on top, whether it's a text field, spinner, or a full table. But so let's officially go to start discussing about graphical user interface or GUIs. So up until now, most of our programs have been text based. You type text in the console and you get output printed back. That's fine for learning the basics, but real world applications usually involve windows, buttons, interactive components. That's where Swing comes in. So creating a window. First, in Swing, everything starts with JFrame. You can think of a JFrame as a window itself, the thing with a title bar, a close button, and a space where all your components will live. So when you create a JFrame, you typically give it a title, set its size maybe 400 by 300 pixels for the starter window, and tell it what to do when the user clicks the close button. This is easy to forget, but without it, your program might keep running on the background. The method you call is set default close operation, like jframe dot exit on close. That's the method you'll be calling. And finally, you call the set visible true, so the window actually shows up. Next is adding components. So of course, a blank window isn't very exciting, so we add components. A JPanel is usually the container we start with. It acts like a board where we arrange things. So inside that panel, you can drop in a J label to display text, and a J button to give the user something to click. So with just a few lines of code, you can spin up a frame, add a panel, place a label and a button on it, and show it on the screen. That will be your first GUI. Next comes event dispatch thread, EDT. So now there's an important detail behind the scenes. All GUI updates in Swing happen on a special thread called event dispatch thread. The rule of thumb is simple. If you're starting up a GUI, wrap it in the Swing utilities dot invoke later. That ensures that GUI creation runs safely on the EDT. And once your GUI is running, don't bog it down with heavy work like reading a huge file or doing big calculations. If you do, the whole interface will freeze. So keep the EDT free for UI updates and more heavy work somewhere else when you need it. And then we have layout managers. So before we discuss an example, one more piece is how components get arranged. So Swing uses layout managers. The simplest is the flow layout. It just places components left to right, wrapping them like text. We have border layout, divides the window into 4 regions: north, south, east, west, and center. And later we have a grid bag layout. We'll use grid bag layout for fine-grained control, especially when you're building forms. So for now, layout, flow layout, and border layout are enough to get started. So here's a small example. You can imagine typing into your IDE. Picture a window with a label that says hello and a button that says click me. If you press the button, the label changes to button clicked. So that's a simple example to start with. It's not fancy, but just a simple way to show how a label, to understand how label and button interact inside a frame. And even with this little example, you'll understand the key swing ideas. You're like create a window, a panel, place components, and react to user actions. So some of the common mistakes to avoid is forgetting the close operation. So if you don't call set default close operation, closing the window won't actually end the program. And then we have another blocking the EDT. So if you do something slow on the GUI thread, the whole interface will lock up. Always keep the UI thread free for user interactions. Yeah, that's the building block for everything else we're going to do with GUI. From here we'll go into some advanced components, but this is your foundation. So GUIs in Swing start with JFrame, use panels and components inside, follow the rules of EDT, get arranged by layout managers, understand the simple hello GUI program, and you'll be ready for bigger examples. Next we have GridBagLayout. So let's talk about GridBagLayout. If flow layout and border layout feels too basic, GridBagLayout is the tool that gives you fine-grained control. A grid you define as you go with cells that can stretch, align, and space out exactly how you want. So think of a flexible spreadsheet. Every component sits at a row and a column. So if you decide whether it grows, how much space it takes, and how it's aligned. So the GridBagLayout is driven by companion object called GridBagConstraints. You set fields on the constraint object, things like the cell position, how many columns to span, whether it should grow, and then you add your components. You basically rinse and repeat. Yeah, let me walk you through some through the core constraints you'll use all the time. First one is gridx, gridy, which is the row and the column. Start at 0, like example, like name label at 0, 0, and name field at 1, 0. That's an example for gridx and gridy. Grid width, grid height are basically how many columns or rows a component spans. Example is maybe the submit button spans 2 columns and the grid width will be 2. So that's an example. Weight x, weight y is basically how many extra space is distributed when the window grows. So if you want text fields to stretch horizontally, give them a positive weight x, like 1.0. If everything has weight 0, nothing stretches, the extra space piles up at the edges. And then we have fill. Fill is basically how the component grows inside its cell. Options you'll actually use is we have none, which is no growth. We have horizontal, vertical, and both. So for text fields, horizontal and both will be very helpful. We have anchor. Anchor is where the component sits inside the cell if it doesn't fill it. So common anchors we have west, east, and center. For right aligning a button, anchor east is what you'll use. insets, which is basically padding around the component, top, left, bottom, and right. Use small insets like 5 to 10 px, so controls don't touch each other. So create one grid bag constraints object upfront before you add each component. Set or reset the fields you care about, like position, weight, fills, insets, it could be anything. Add the component with the constraints and then adjust the constraints for the each component. Why one object? Because it's efficient, but it's also where people get into trouble, which leads to issues in a minute. So let's say so let's say you're working on a simple form together. We want row 0, which is name label, then the name text field, row 1 email label, and then email text field, and row 2 it's an empty spacer on the left and the submit button on the right, aligned right. So you start with the JPanel using the grid bag layout. You create a grid bag constraints, something named C. Give C dot insets a small padding, say 8 pixels all around, so things breathe. That's an example. So some of the things to remember is reusing the same grid bag constraints without resetting fields. That's one thing to remember. So grid bag remembers whatever you set last time. If you set grid width is equal to 2 for the button and forget to set it back for the next component, suddenly the next component also spans 2 columns. So that's what I call layout drift. So the fix is, before each add, explicitly set the fields you care about, especially grid x, grid y, grid width, grid weight x, fill, and anchor. Another thing is forgetting weights and fills. So if nothing has weight x, the layout won't stretch on resize. If fill is none, your text field stays tiny even if the cells gets big. The fix for that is on the fields that should grow, use weight x is equal to 1.0 and the fill is equal to horizontal. That way you can fix it. Another thing is no insets. Components jammed together look broken. Fixes, you can fix it by setting small insets once and reuse them. And another thing is overusing grid bag for simple rows. So if you only need a straight row, flow layout might be simpler. Use grid bag when you need alignment and growth rules. So if you follow this mental checklist, set position, set growth, set alignment, set padding, grid bag layout becomes predictable and you can make forms that look professional without fighting the layout every 5 minutes. That's it about grid bag layout. So in the next segment we'll wire inputs to listeners and start making the form do something. So next topic is, now that we have got components on the screen, we'll make them actually do something. That's where events and listeners come in. So in Swing, every interactive component like a button or a text field can fire events. A button fires an event when you click it. So a text field can fire an event when you press enter inside it. To handle these, we attach a listener, basically some code that says when this event happens, run this block of code. So the most common one you will use is ActionListener. Buttons use it. Text fields can use it. Even menu items can use it. So how to add listeners? There are few ways to add listeners. The older way is with a anonymous inner class, which looks bulky but still works. The newer, cleaner way is to use a lambda function expression. Since action listener is a functional interface, you can write something like button dot add action listener do something. This is shorter, easier to read, and keeps the focus on what happens when the button is pressed. So, but here's an important best practice is don't cram all your business logic inside the listener. Keep your listener short. It should just call a method that does the work. That way your GUI code and your program logic stays separate. And when users type things in, you need to validate it. For example, maybe they typed an empty string when you need a real text. If the inputs is invalid, show quick feedback. The easiest way in Swing is to use the JOptionPane. If it can pop up a simple dialog box with an error message, a warning, or just information. So if someone clicks add without typing anything, you can show you can show something like JOptionPane dot show message dialog, let's say frame comma please enter a name. This is fast, simple, and gives the user immediate feedback. So imagine a small program with a text field, which user types a name, a button labeled add, a list that shows all names entered. So when the user types a name, clicks add, the user should read the text from the field, check if it's non-empty. If it's empty, show a message dialog asking for input. If it's valid, add it to the lists model using a default list model, and clear the text field so it's ready for next entry. So that's a complete simple cycle: event, validation, action, feedback. So couple of things to avoid: don't do heavy work inside a listener. If the button click needs to read a file, connect to the internet, or do a long calculation, don't run that directly in the listener. It will freeze your whole user interface because listeners run on the event dispatch thread. In real world apps applications, you'd hand that work off to the background worker like a Swing worker. And don't forget to reset controls. After you add something to the list, clear the text field. If an action makes a button temporarily invalid, disable it until it's ready to be used again. A little cleanup makes the interface feel polished. So yeah, listeners, make your GUI interactive. Attach them with lambdas. Validate input before using it. Use dialogues for quick feedback. Keep the heavy work of the UI thread. Understand this pattern, you can start building real usable GUIs instead of just static windows. Next topic is JFormatted text field. So next, let's look at a tool that makes your user input safer and less error prone, the formatted text field. So normally when you use JTextField, it just gives plain text. If we want a number, a date, or a specific format, we want to parse it ourselves. And if the user types in garbage, the program blows up. A JFormatted text field helps by reinforcing format right at input time. So why formatting matters? Imagine you're asking a user for a price. With the plain text field, they could type like 1 to 3 ABC. With the formatted text field, you can say this field must be number, or this must be look like a date. It saves you chasing down bad input later. So using number format, date format, the easiest way to set one up is with the number format or date format. So for numbers, you can do number format dot get currency instance, or number format dot get number instance. For dates, you could use date format dot get date instance. Or something similar. You pass this format into JFormatted text field, and now the field automatically enforces it. If the user types something invalid, the field won't accept it. There's a detail here. When does field actually apply the value? So by default, formatted fields try to commit changes when they lose focus. For example, when the user tabs away, that works, but sometimes you want to commit earlier. That's where set commits on valid edit true comes in. It tells the field as soon as the input is valid, treat it as committed. And you can also call commit edit in code to force it. That's handy if you want to process the value right after the button click, not wait for focus to change. So suppose we are building a form where the user types a product price, and we set up JFormatted text field with number format dot get currency instance, and the user types something like 19.99. So when we need to read it, we call get value. That gives a number. We can safely cast to a double. Then for feedback, we display the value in the J label. Maybe show it back with tags added. So notice what we didn't do is we didn't call get text. That would just bring us raw string, which may or may not be valid. So using get value ensures we are actually getting a proper number. So some mistakes to avoid is use get text instead of get value. So if you do that, you're just back to parsing strings yourself, which defeat the purpose of formatted field, and not handling parse failures. So if the user somehow somehow entered something invalid. Calling commit edit may throw a parse exception. You need to catch that and either show an error or reset the field. So formatted field text fields are your safety net for structured input. They let you say this field must be a number or a date or a currency. They save you from cleaning up messy user input later. Use them whenever you need structured data, and always remember to use get value instead of get text. So this will make your GUIs more robust, and it will cut down on those why is my input crashing the programs bugs. So yeah, so the last topic for this session is JSpinner. Let's look at some this is another useful input component. A spinner is exactly what it sounds like, a small box with little arrows that let the user step through values. So instead of typing numbers or dates, the user clicks up or down, and it's great when you want input to stay within clear limits. So we have different models, spinner models. So every spinner is powered by a model. The model decides what value the spinner can show and how it moves between them. There are three common ones you'll see. SpinnerNumberModel for numbers. You give it a starting value, a minimum, a maximum, and a step. Like example could be new spinner number model, let's say 1, 1, 0.1. Actually we missed one. Let's say so it starts at 1, can go to 10 step by 1. So yeah, that's a simple example. That's a syntax. So next we have a spinner date model, which is basically for dates. Lets you step through dates, days, months, or years. We have a spinner list model for stepping through a fixed list of items like a set of strings. For most of our work, you'll be using number model. When you want to know what's in the spinner, you call the get value. Here's the catch: get value returns an object, not a primitive. So if you're using a number, you'll need to cast it. For example, integer spinner dot get value. So to respond when a spinner changes, you can attach ChangeListener. Every time the user clicks the up or down arrow, the listener runs, and you can update the rest of your UI. Example, like imagine we are building a small order form where the user picks a quantity. So when you create a spinner with spinner number model 1, 1, 10, 1, so they choose between 1 and 10, stepping by 1. So next we have a label showing the total price. Let's say unit price is $5, and when the spinner changes, the change listener grabs the new value, multiplies it by 5, and updates the label. So if the user picks 3, the label says total 15. So that's clean, interactive. It's a small example, but so few things to avoid, to watch for with the spinners is forgetting the get value returns an object. So if you try to assign it directly to an integer, you'll get an error. Always cast it to the right type. usually integers for number models, and not setting bounds. So if you don't give a minimum and maximum, the spinner keeps going forever. Sometimes that's okay, but most of the time you want to keep it within limits like 1 to 10. Yeah, spinners are perfect for when you want users to pick from a controlled range of values. They're simple to set up with right model, and they keep your input safe and predictable. Think of them like a drop-in replacement for text fields. When you know the valid values are numbers, dates, or small fixed set of items, use them whenever you want to prevent bad inputs, keep things easy for the user. That's all for this session. We'll cover the rest of the topics in the next session.